Hello. So all of my recent videos have been on blockchain security and smart contract security in particular. Um, but I've noticed that in the blockchain industry there's a lot of misinformation and many things are misunderstood. So I just thought it would be a good idea to also do a course on blockchain basics, where we step back from security and look at how the blockchain really works. And before we actually get into the details of the blockchain internals, in this first episode, let's just look at the problem blockchain tries to solve. So the problem the blockchain tries to solve is easily explained but difficultly solved, like many good problems. And it's basically that there's a network of participants, which are all equal, and they have to maintain a ledger of transaction, a history of events, or a history of things that have been going on in the system. And the main idea is that all of these nodes are equal and can send transactions to the network, and these have to be verified and put into a unique order that is replicated on all of these nodes. And there's some conditions, some properties attached to this. Obviously, as I've already said, all the copies of the ledger have to be exactly the same. And there's no coordinator in the system. Of course, this problem is easily solved if you have sort of a central database that just distributes its view of history to the other nodes. But in this case, all of these nodes are equal. It's a true peer-to-peer network. So there is no coordinator, and all these nodes have to come to consensus on what the order of transactions should be. And of course, this ledger can contain a number of things. For example, in cryptocurrencies, this is balances and transfers, but it could be other things. But it has to be a record that should be immutable, which is the third property, really. Immutable means you cannot alter or remove a transaction from the history. And obviously, when we say mutable here, we really mean if there was someone trying to alter the blockchain or the history of the ledger, the history of transactions on the ledger, then that should be easily detectable, and so no one can cheat the system. And the other assumption here is that participants may not be honest. That makes the problem even harder, because nodes may not just fail by crashing. They may also fail by trying to cheat the system, alter the ledger, send transactions that are untrue, or for example, spend an asset that is not available, that sort of thing. And yeah, this honesty property is really what makes this so difficult. And then here the final property I put in parentheses, and it basically it means that anyone can participate. But it's in parentheses because it's not true for all blockchains. But in a public blockchain, we assume that anyone can participate, which of course means we do not know the number of the nodes that have to reach a consensus. Anyone can join the system, and as such the nodes may be more or less at a certain given time. And now in a consortium chain or a private blockchain, that's not exactly the case. Nodes are authenticated, and we know who's part of the system. But anyway, assuming we have an open system, that makes the whole thing much more challenging. And this problem is also known as the Byzantine generals problem, which is a classic problem in computer science. And now I don't want to go into too much details, but basically this is sort of a metaphor for all this problem, in which a number of generals have to come to consensus on whether to attack a city or retreat. Now, if they coordinate themselves and do the same things, they survive or win the battle. But if some traitorous generals just retreat, meanwhile others attack, then they lose the battle. Now obviously these generals, they don't trust each other. They have to find a way of reaching a consensus without having to trust them. And I just sort of included this here because this problem was already described and solved theoretically in 1982 in a paper written by Leslie Lamport and his co-authors. And it was sort of practically solved in 1999 with an implementation of an algorithm for voting that is still used right now, up to this day in a lot of consortium blockchains. So this just goes to show that not everything in blockchain is completely new. Whilst the Bitcoin, when it came out in 2009, was a very innovative system and provided a lot of interesting properties, it all builds on earlier distributed systems research, which hasn't gone away certainly and is still used. I think that's important to realize. And another thing that people should realize is what the blockchain actually can do and what it provides. Because there's a lot of misinformation there, and there are some projects that assume certain properties of the blockchain, which is just not true. So the blockchain provides a unique version of history of transactions. So there's this consensus where nodes all reach the same list of transactions. And that gives us a mathematical foundation that we can use to replace trusted third parties. So now we don't need this central database like a bank that keeps track of balances on accounts anymore. We can do that through a mathematical protocol in a distributed way. And that's very powerful. And it's also a solution to the double spending problem. Now, the double spending problem is simply the fact that sort of a digital currency or a digitized asset could be used many times, because it's not like cash that once you hand it over, it's it's obvious that someone else has it. But in a digitized system, that's not as easily done, especially not without a central coordinator. And there's also an auditable, immutable record. So everyone can always look up this history of transactions and make sure it has not been altered. And everyone can see what transactions have happened and where the assets are. And these properties made asset digitization possible, which is why we can now tokenize almost anything, which is very powerful. But these properties, that's what the blockchain provides. So the number of things that it does not provide, also a lot of people tend to claim this on a daily basis. The blockchain cannot provide extra privacy. Now, by default, the blockchain, there is no privacy. Transactions are public. Obviously, you can build privacy systems on top of the blockchain and you can use certain techniques. But that's not a property that comes from the decentralized network of the blockchain. It's nothing the blockchain adds. So there's no extra privacy in blockchain systems. There's no added security. Yes, there's a public key infrastructure, which is generally very secure. But you could do that without a blockchain. You don't need the distributed set of nodes, the peer-to-peer network to do that. The blockchain cannot easily interact with external data or devices. It's very difficult to get data onto the blockchain and interact with the outside world. But that's important, and that's something we look at after in one of the following videos. A blockchain also does not improve the performance of an application. Yes, there is this decentralization that things are executed on a lot of nodes, but all these nodes execute exactly the same. It's not like parallel computing where you split the task. So that's something that is often represented. Normally, when you introduce a blockchain, you actually reduce the performance of an application. It's always easier to build a fast, centralized application. So this also means that you cannot store large amounts of data or perform complex operations directly on the blockchain. Because if every node has to store everything and every node has to execute everything, then you're sort of limited to the slowest node and the one with the least storage. So yeah, you have to be careful what to put on the blockchain, and there are a lot of projects out there that claim to put large amounts of data on the blockchains, which they really can't. It doesn't work like this. So, and then this final point here, I think that's very important, and a lot of projects seem to completely misunderstand this. Just because data is written on a blockchain does not make it true, right? Very often these IoT applications, Internet of Things applications or similar, seem to assume that if you have a data source and you make this data source submit data to the blockchain, then that sort of the blockchain magically provides some sort of truth oracle. I mean, the blockchain does not prevent fake news. If I write something false onto the blockchain, there's no one stopping me from doing this, right? So that's very important. And there's some AI projects out there that see the blockchain as sort of a way of keeping artificial intelligence secure and honest. And I don't think that's the way the blockchain should or can work, and there's a big misunderstanding there somewhere. Anyway, this video has described what the blockchain tries to solve and what it does provide, which is powerful, but I think it was also important to state what it cannot do, and as I said, there's a lot of misconceptions there. So in upcoming videos, we look at cryptography and how the blockchain works under the hood, and yeah, I'm looking forward to that.